Good evening. My name is Serban, and I'm a teaching assistant at University Polytechnica of Bucharest, Faculty of Transport, more precisely from Transport, Traffic and Logistics Department. And with the help of my colleague Alina, Eugenia, Armand, we conducted the research entitled on flow consolidation modeling in urban congested areas. Our presentation is structured in 4 chapters. In the first one, we will present the issue regarding the flow consolidation in urban areas. In the second chapter of the presentation, the methodology of traffic flow consolidation for both simple and multiple consignments. In the third chapter is the case study of our research on the traffic flow consolidation for both simple and multiple consignments in urban area, and the conclusion of our research. We all know that freight distribution of goods in large urban areas represents one of the major challenges due to its importance in the economic functioning of the city, as well as its impact on the quality of life of its inhabitants. With the significant increase in freight deliveries in urban areas, decisions on freight transport are becoming more and more important. Therefore, urban logistic policies aim to optimize logistic activities in urban areas with the support of advanced information and communication technologies that shall be oriented towards sustainable development. Therefore, the main problem that arises in urban freight distribution is that it represents there is a significant percentage of vehicular traffic in cities, which is considered to be between 15 and 20%, which lead to a key role in the framework of sustainable development of urban regions. The problems that are generated by freight transportation are increasing due to higher population densities, increasing demand for different types of goods, and increasing the levels of congestion, air pollution, and noise. Therefore, urban freight distribution is regarded as one of the main contributors to the continuously growth of traffic congestion levels and environmental pollution in urban areas. And one solution that can be used in order to solve this problem is to apply different consolidation schemes for the traffic flows with different origins and destination at the boundary of urban congested areas. This is the main objective of our research, to identify a method that can help us to consolidate traffic flows in urban congested areas, and create a methodology that help us in this matter. The first methodology that we use is absolute calculation method for flow consolidation. Identifying the optimal solution to consolidate urban traffic flows, it involves the calculation of indicators for each consolidation option that we can find. The relationship noted with number 1 is a requirement that it is entitled a sufficiency one. In this relationship, the first term, QIG, is the flow from center I to center G. The term sum of theta economy, EC, is the total time savings resulting from the transit without processing through the centers on the route by the longest distance shipments, while the product CM is the pallet's consumption hour for accumulation. In case one flow from one center to another do not meet the requirement, it is checked whether the combination with a neighboring traffic flow respect this condition. If the relationship is not fulfilled, even in this case, that palletized good flow will not be taken into account in future calculation. Otherwise, if the condition is met, it will move to the consolidation option in the combined form that satisfied this relationship. In order to apply the algorithm for the identification of the consolidation variant of the palletized flows, certain steps must be followed. The first of them supposes to introduce and calculate some parameters. K is the number of terminals or distribution centers. The second term is the flow between the one center to another. The third term is the time savings that result by processing that flow in that terminal. Ck is an accumulation parameter. M is the size of a shipment in terms of the number of pallets that can be transported, while the last term is a product that is the pallets consumption hours for accumulation at the warehouse. Then we go to the verification of the number of urban centers considered in the analysis and compute the consumption of pallets equivalent hours for each of the urban centers, from which we'll extract only and analyze only 3 variants with minimum consumption of pallets hour with the characteristics corresponding to the best option for consolidated traffic flows. In order to calculate these solutions and compare them, we must know the number of variants that shall be analyzed, and which are calculated with relationship number 2. This method, in case of higher instances of the problems, means that the number of the variants that must be taken into account increases, and it is not as performant as the next one, the conjugate analytical comparisons method. This method is based on analyzing traffic flows and their separation in different conventional relationships in the optimal way of consolidating urban traffic flows. In order to apply this method, the flow from one center to another shall respect both relationship number 1, the necessity condition, and the relationship number 3, which we will call from now on a sufficiency condition. In this relationship number 3, the term theta, sum of theta erm, is the time savings due to the transit without processing of shipments through the urban centers along the way. The steps of the algorithm that we used in our research in order to find the best solution of combining traffic flow is outlined in table 2.1. We also provide a third method that can help us in identifying the optimal solution of combining traffic flows. This method, the direct analytical calculation method, is based on the principle of classifying the urban flows in 5 different categories. The first one, the basic palletized flows that specialize unconditionally, which includes those traffic flows made up of one or more current of palletized goods that satisfies this relationship. The second category, basic palletized flows, are that category which, when transit without processing through a warehouse, provide an economy at least equal to the consumption of pallets hours for a single destination. There are other 3 categories: additional palletized flows, unifying palletized flows, and completion palletized flows, which must fulfill the last 3 relationships. Regarding the steps needed to apply algorithm for the identification of optimal solution of consolidation of urban traffic flows for a single destination, the steps that must be fulfilled are shown in table 2.2. We must make some comments about this algorithm. After separating the currents of goods palletized into basic currents that specialize unconditionally, basic and additional, we proceed to check the beams that can be included in the category of unificable flows. The beams that will be analyzed can be included in different variants of combination of those that can be included in the category of unifiable currents. It will be calculated for each variant the resulting economy of pallets hour, and we will choose the variant for which the economy is maximum. Not only that, we should analyze the possibility of identifying the traffic flow consolidation for simple destination for single destination, but we should analyze the possibility for the multiple destination. The method for multiple destination is similar to the one presented for single destination. The process of consolidating both traffic flows for one or multiple destinations can be done simultaneously, which means that the number of possibilities to guide the traffic flow is significantly higher compared to the situation of the consolidation for a single destination. Supposing that we have a distribution system made of 4 terminals, the number of possible solutions of flow guidance is equal to 79. To these are added a number of another 9 solutions which correspond to the formation of expeditions for single destination, but many of them can be excluded. The given correlation in the flow size, the number of solutions that should be analyzed for flow consolidation for multiple destination will be reduced to 22. In essence, the algorithm that allows the consolidation of grouped urban traffic flows must facilitate determination of pallet consumption hours for each variant of consolidation of shipments for a single destination. Subsequently, the variants to be calculated based on the existing link between the number of palletized goods corresponding to each urban center, but also the calculation of consumption of pallets hours of the chosen variants must be chosen. Then we should choose the first 3 options with the lowest consumption and possibility of practically application of these solutions. The logic scheme of the diagram of this algorithm is shown in this picture in this slide. Then we go to the case study of our research. In order to achieve a feasible and sustainable logistics solution, a collaborative logistics scheme that contains a number of 4 distribution centers will be chosen, and it is shown in the picture on the left side, where below this picture we presented the hypotheses that were taken into account. In order to show how the proposed methodology works, we took into consideration 3 urban distribution scenarios. The first one, in which only 3 of 4 distribution centers have accessibility according to the supplier's requirements. Scenario 2, in which is pretty similar to the first one, but the main difference is that the segment of the road network on which the urban distribution centers are located has been closed. And the third scenario, which is similar to scenario 2, except that in this case the possibility of consolidating the grouped urban traffic flows is analyzed. The results of these scenarios are now presented. In image 3.21, we presented the palletized goods flows from suppliers to the 3 urban distribution centers according to scenario number 1, while in figure number 3.21 are the flows according to the scenario number 2. In case of the scenario 1, it is assumed that only 2 of the 4 urban distribution centers have accessibility according to the requirements of the suppliers. Their flows are outlined in figure 3.21, and in this scenario, the consumption of pallets accumulation hours in center 1 and 3 is considered to be equal at 200 pallets hours. Taking into account the load capacity of each vehicle, the size of the parameter that characterizes the accumulation of pallets, the number of groups of pallets that make up the shipment, it can be seen that the option of consolidating urban traffic flows that guarantees the minimum is equal to 1,200 pallets hours, which is justified by the fact that the only possibility of combining flows from this distribution center 1 to 3 and 1 to 4 is not recommended, as there are not the time savings are not so high. Scenario 2 assumes that all 4 distribution centers considered can be used by suppliers, which generates the flows of palletized goods in the figure 3.21. In this situation, all 9 possible flow consolidation options given by the absolute calculation method must be analyzed, and the one that guarantees the minimum as well as the optimal solution given by this method must be identified. By analyzing all 9 possible solutions for each direction, for center 1 to center 4 and for center 4 to center 1, we can see that the solution that gives the minimum consumption hour is solution number 7 for center 1 to 4 direction, while for center 4 to center 1 the optimal consolidation solution is indicated by variant number 9. If we apply the conjugate analytical comparisons method, it can be observed that traffic flow from distribution center 1 to 4 meets the sufficiency condition, while for the other direction the traffic flow from center 4 to 1 meets this condition. Therefore, they will be automatically included in the optimal consolidation solution. For both directions of transport, it must be analyzed whether there are savings in pallets hours as a result of the transit of the respective urban traffic flow, or combined with other flows also, through the distribution center and the itinerary. The solutions are shown also in figure 3.23. Also, in case of direct analytical calculation method, we can see that flows from distribution center 1 to 3 and from distribution center 3 to 1 are basic urban flows that specialize unconditionally. There are no traffic flows that can be included in the category of basic flows. Traffic flow from center 1 to 4 and from center 4 to 1 are additional flows, while those flows from center 2 to distribution center 4 and from distribution center number 2 to 3 are this are 4 to 2 are complementary. We move to the next stage in of the analysis of the possibilities of consolidation from the perspective of pallet savings hours that can be obtained as a result of the combination of urban traffic flows, which lead to the solution found in figure 3.23. We also analyze the possibility of traffic flow consolidation for multiple consignments, which lead to a number of 22 scenarios that shall be analyzed. There must be an observation made that in case of the size of traffic flow between two distribution centers, or the sum of the flow starting from one center and being processed, then the respective consolidation option will not be taken into account. And here are the conclusion of our research. Thank you very much, and we're waiting for your question.